Hey, what's going on, everybody? It is me. It is the OG, the original gamer, Stevie Stroh, lifelong CoCo nut, and we're back for more programming and basic on the Tandy color computer. We're in section 2, which is called Sights and Sounds, which is going to cover things like drawing a circle, painting a house, composing a song, cooling off with a cube, and much more. So we're now in the part of the book where we're going to get graphical. But here's what's confusing me right now, and because the only excuse me, the only book I've had to work with to do this that I can distribute electronically has been a PDF copy of a extended color basic manual for the color computer 2. And the way I learned basic, which I'm kind of thankful for, I kind of learned it in baby steps. But I learned it in 2 different books. I learned it initially with this book here that's called Getting Started with Color Basic. And Getting Started with Color Basic does have graphics and sound capabilities, but they're all low resolution. Low resolution, very blocky, using basically a text-based graphics mode. And from what I can tell, this manual that I'm working from right now doesn't even cover those modes, because it's going straight to high-res graphics, which, you know, for the sake of somebody who wants to see something cool, that's cool. And so the second CoCo I got, which had Extended Color Basic, had this one here that's called Getting Ahead with Extended Color Basic. Now, I wish I had PDF copies of these and I could have gone through both books in order, and we learned the basics of basic first and then learned the extended basic commands second, because I had a year or 2 working in normal color basic, and I was forced to work in very low resolutions, and I made some pretty cool games with low resolution graphics and with text-based graphics, as making the screen scroll so it looks like you're driving a car and things like that. So if I can't find an electronic version of the normal color basic, I'm gonna probably just do it myself, and I won't have anything to show you side by side with, so you just have to follow along on the screen, and I'll just read it off. But I think I've got 2 copies of this book. This one's in really good shape, so I might consider sacrificing one of my copies and scanning it, because I'm gonna have to destroy the book to scan it. But it might be good for the sake of the color computer archive and preservation and everything else to maybe sacrifice one of those books and scan it and get a good clean scan of the original wide form manuals. I also wish I had had them for this series, because I could have brought it up on screen and it would have fit the entire screen, so I could have referred to what I was talking about in a way that would be easier to read. But it is what it is. I also figured I would show you real quick what my setup looks like, and it's kind of hard to see this screen here because it's very glary. But right here in this big bright white window here that you can't see because of the glare, that's the PDF of the manual. And this little window here, this is VCC running my color computer 3. Here's my Windows keyboard. Here's my real CoCo 3, which I need to look at sometimes to see where keys are when I can't find the keys, but I think I've fixed that problem with OS 9. So this is kind of the setup. I've got 2 screens, so every now and then you're going to see me turning my head over here because I got to read that screen, because what I'm looking at here on my screen is even a smaller condensed version of that. Sometimes it's hard to read the print. But I have, you know, I have this mode here that I use most of the time, where I can fit the entire page on screen here, as you'll see over here, right? You can see the entire page on screen, but honestly, I have no idea how this looks when you guys are watching this on YouTube. I don't know if you're watching this on a full-size computer screen and if it's legible. I don't know if you're watching this on the phone. I actually have no idea how people consume this content. But I've also set up one here, excuse me, where I'm going to make the CoCo screen as big as I can make it when we get into graphics, where I want you to be able to see everything on the CoCo as clearly as possible. So we're going to mess around like that. So let's go ahead and jump in, and let's start off section 2, Sights and Sounds, and let's jump into chapter 14, which is called Let's Get to the Point. I'm really excited about doing graphics now. Everything we've been doing so far on this nuclear green screen has been very text-based. It's been very scientific. Now we're going to have some things that are a little bit more visual, hopefully a little bit more fun. So One of the most exciting features of Extended Color Basic is its ability to display precise, varied, and easy to use graphics called high resolution graphics. Just how easy to use are these graphics? Well, let's start off with the most basic, pun intended, graphic element, a dot or point, and build from there. Extended Color Basic makes it simple to put a dot on the screen. Type in the following program and see. Here we go. Graphics, everybody. Line 5. We'll have to click in my VCC so it'll accept my keyboard. Line 5, space, PMODE 1, 1. PMODE stands for page mode. There are different page modes. And the page modes, the different modes have different levels of graphics resolution. So I think it goes from PMODE 1 through 4, or from 0 through 4, or maybe 1 is the lowest and 4 is the highest. And the even and odd numbers modes are what are either a black and white or a color mode. I don't remember exactly. We'll find out soon. Okay, 10 is PCLS. So you recall we've done CLS, where we can clear the text screen. Because we now are going to clear a graphic screen, we need to do, wow, excuse me voice, we need to do PCLS to clear the page of graphics. 20, screen 1, 1. And again, there's a way to do this, and I don't remember the different screen modes, but I think 1, 0 would do one color set and 1, 1 would do the other. We're going to have to be reminded. 30. PSET. And we're doing this in parentheses now. 10, 20, 8. And if I'm not mistaken, I'm thinking this is the X coordinate, which is the horizontal, the Y coordinate, which is the vertical, and then the 8 would be an actual color. In this case here, this would be the highest color because we've got 8 colors, which we can display in 2 of 4 different. I know it's making that. There's 8 colors. One screen mode will show you the first 4. The second screen mode will show you the other 4. So when we do screen 1, 1, we're doing the higher color set. So we're seeing the high 4 colors. If we did screen 1, 0, we'd see the lower 4 colors. So the lower 4 colors has a green background and has like yellow, red, and blue. The higher color screen has the white background, which has the cyan, magenta, and orange, which is a really odd combination of colors. And then line 40 says go to 10. No, 40 says go to 40. So it's just going to end the program. All right, so let's go ahead and run it and see what happens. Okay, yeah, so this is the high color mode. And here's the pixel right here. This one little pixel here. So because we have the white background, that's the screen 1, 1. If I had done screen 1, 0, the background would have been green, kind of an olive color, and this color here I believe would have been red. I believe red was the high color on this mode here. Because line 40 is going to itself, there's nothing else I can do right now. What do the side notes say here? A 10,600-mile journey starts with a single step, and even the Mona Lisa begin with a single stroke on a canvas. A Jackson Pollock might begin with a single splatter. Okay. Don't worry about any of the new words, PMODE and screen, for instance. Don't worry about any of the new modes. PMODE and screen, for instance, determine the degree and detail and range of colors. They are covered in later chapters. Okay, so there you go. Breathe in, breathe out. But yeah, we just put a dot on the screen. We put a pixel on the screen. And because we've done a relatively low resolution, PMODE 1, it's a rather large pixel. It's a very visible pixel for right now. What does this say down here? PSET. PSET lets you set a dot anywhere on the screen, and it has this format. H is the horizontal position, which goes from 0 all the way in the left to 255 all the way in the right. So there's 256 possible pixels from 0 to 255. Y is the vertical, which goes up and down, and this can go from 0 to 191. So there's a total of 192 vertical pixels and lines. Okay, so C is the color from 0 through 8. If you omit C, BASIC uses whatever the current foreground color is, meaning the last color you've used. And it says, you'll see these syntax blocks. They'll help you understand the parameters you can use with graphic statements. So, even though you can't see it, the computer has divided your screen into nearly 50,000 dots. 256 across by 192 down. So you can put a dot precisely where you want it. Simply look up the dot's position in the graphics worksheet on the back of this manual and look at line 30 again and see how PSET specifies the dot's position. 10 over, 10 across, 10 is the X or horizontal, 20 down, which is the Y or vertical, and then 8 is the color. Here's the statement you would use to set an orange dot in the center of the screen. So we would say 128, which is dead center. 128 is the middle of 0 and 255. 96 is dead center. 96 is the middle of 192. And then 8 is the highest color. Now it says, now add a program line that sets an orange dot in the lower right hand corner. So why don't we do that? So you'll see we've made your point. Run the program again and you'll see. Now the program looks like this. So let me break out of my program. I'm going to hit end. I'm going to hit list. So 5 is PMODE 1, 1. 10 is PCLS. 20 is screen 1, 1. 30 is PSET 10, 20, 8. 35, we're now adding a new line between 30 and 40. And that's the cool thing about BASIC, right? When you list your line numbers, you're going to see them sequentially. But what if you need to put something in the middle? Well, if you've got space in there, you can insert this as an intermediary line number. So we typically did things 10, 20, 30, 40 to give us a nice gap between line numbers, and we could then insert line numbers between lines. There is also the renum command, which I think I've already covered, where you can renumber everything and resort them sequentially at given times. So in line 35, PSET 255, which is far right, in this case here, if you're looking on the video, far right, comma 191, which is bottom corner over here, yes, over there, comma 8. And so now when I list that out, okay, so we set the P mode, we clear the screen, we do screen 1, 1, we do PSET 1028, which is up here, and then we do PSET 255, 191.8, which is down here. Let's run it and let's see what happens. Okay, kind of hard to see, but here you'll see the one that's in the kind of sort of top corner. Here's the one that's in the definite bottom right-hand corner. Why don't we do this? Why don't we do top, middle, left? So I'm going to redo line 30. I'm going to say line 30, PSET 0, 0, 8. That's absolute top left. Line 35, PSET, and then I'll do line 31, PSET 128, 96, 8. That's dead center. So when I list this out, I've got top left, I've got dead center, I got bottom right, right? So 0, 0 is the top left corner, 128, 96 is dead center, 255, 191 is bottom right-hand corner. Let's run this. And then here's our 3 pixels kind of going in a diagonal line, right? So this pixel here is in the top left. This pixel is in the center. This pixel is in the bottom right. Now what I did is I've actually trimmed off the border. So there's actually a bigger white border around this. This is the actual usable space for the most part that's on this CoCo screen. But if you're looking at this on a real CoCo or on VCC, you're going to see a bigger white border around the area where your pixels are. Don't be alarmed by that. But yeah, so this is 0, the 0x and 0y, top left-hand corner. This is 128 across, which is dead center, and 96 down, which is dead center on the y. This one over here is 255 on the x, which is far right-hand corner, and 191 on the y, which is all the way down. So these are top left, center, bottom, right. Now, I'm sure the chapters are going to cover this, but I'm just going to throw this out here too. The different P modes actually have less resolution, so the pixels end up getting bigger. So I think P mode 1 was the lowest resolution. So as I'm thinking about this, I think 0 and 1 were the same mode, but just black and white in things. And then 2 and so 0 and 1 are super low. 2 and 3 are medium resolution, and then 3 and 4 would be high. 3 would be the color mode. I don't know. I'm confused. Whatever. The book will get us there. I'm trying to remember, and I haven't read ahead, so I apologize. Anyways, we're going on. What about the color? By now, you've probably figured out that you can change colors by changing C to a different number in the range of 0 through 8. Within limits, this is true. However, and it's a big however, you may not get the color you specified. And there's a good reason for this. We'll cover that later in the discussion of the different graphics modes. For now, don't worry if you don't always get the color you want. But here's a list of the color codes. Now these color codes are based on the text graphics, okay? So 0 is black, 1 is green, 2 is yellow, 3 is blue, 4 is red, 5 is buff, 6 is cyan, 7 is magenta, 8 is orange. So I think that kind of works out. I think these here kind of work out because this is one of those screen modes. We're in screen mode 1, so this is our first color. This is also, technically these colors become kind of relative, so this becomes like 0, 1, 2, and 3. So in screen mode 0, we have a green background. Green becomes color 0, which is the null blank color. Yellow is our first color, blue is our second color, red is our fourth color, right? So that's one screen mode where you're going to get just these colors here. The other screen mode, you're going to get these colors here. They call white buff. Don't know why they chose that name. Cyan is kind of like your teal color. Magenta is like kind of a nuclear purple, and orange just hurts your eyes, right? So it says, if you want to change the dot's colors, use buff for 5, cyan for 6, or magenta for 7. Then change the color back to orange before proceeding. These 4 colors are the only ones available in your current program. Now you see it, now you don't. Any guesses on how to turn a dot off? Any guesses on how to turn off a dot? Here's a hint. It is easy, and it has to do with color. You see, you don't really turn off the dot. You simply change its color so that it blends in with the background. You do this with the new statement P reset or point reset. Preset knows you want to use the background color, so you don't need to give it a color. So whatever your normal background color is, it will use. So if we do a preset and we just do H, V, preset horizontal spot, vertical spot, and don't specify a color, it will just reset that color to whatever the background color is. So that's the command preset. It's kind of like a reset, but we're doing it on high res mode, so we always put a P in front of that. Now it says do it yourself program 14-1. Get to know the dot positions on your TV screen by using your graphics screen worksheet. Several points on the worksheet, select several points on the worksheet, identify them in terms of their X and Y coordinates, and display them on the screen using a program we used to get you started. Don't change any program lines except the ones that contain the PSETs. And so they're asking us to look for this worksheet. I need to find this worksheet right now. Let me, section 2, getting down to business. Let's see, chapter 34, section V, odds and ends. Is this where it's at here? I don't even know. Let's see if I can find it. Suggested do-it-yourself programs, sample programs, graphics worksheet. So yeah, here's the different graphics worksheet modes. So this is a graphics mode, which is now bigger than I can fit on here. But this is one of our resolution modes that is 128 across by 192 down. And so this is basically showing you a very fine point graph paper grid on what your screen looks like, right? So we have a graphics worksheet that has 128 across, and I think you probably have to turn this book sideways to see it. I'm thinking that this is actually the vertical and this is the horizontal. So that is the graphics worksheet of 128 by 90. And we were just having this conversation the other day. I think it was David Ladd and I were talking about this, where when you wanted to do graphics, it wasn't uncommon to have graph paper and buy the graph paper, which was this blank paper with grids on it, and you could kind of fill in your graph paper and plot out how you wanted to do things. So this is one of your graphics worksheets. So this is the lowest resolution mode that has 128 across by 192 down. Then we get into a high resolution mode, which is 256 by 192. That's the high resolution mode. Then we've got a 128 by 96. That's a medium yeah, I'm getting confused on these numbers here, right? So technically this is PMODE 3, I think. This is medium resolution. PMODE 3, which has 4 colors, gave you 128 across. Okay, PMODE 4, which was our super high resolution mode that was technically black and white, that's 256 across by 192 down. And then we had our PMODE 1, which was a lower, bigger, blockier resolution that was 128 by 96. So not only were the pixels twice as fat, but they were also twice as tall. So that's the mode that we're running in right now with these big fat pixels. And then here's the set and reset worksheet. This is how we, okay, so this is set reset worksheet. I wish I could make this thing show up properly on, let me see if I can't, fix the cropping on this because it's kind of weird the way this is showing up right now. I don't know. I can't see it just right, but if I make this bigger, okay, now it just looks like crap, but you can at least you can see it all in screen. So this one, I think you would also have to turn your book sideways, but your set and reset, this is the low resolution screens. So this one gave us 64 pixels across by 32 pixels down. And each of these pixels is actually one text character that's broken into 4 blocks. This is the low resolution mode that I also want to mess with, and I'm kind of disappointed that it's not actually giving us these lessons in this book, but we'll get to it, no fret. All right, so then we have the print at worksheet, and this is where you can print stuff on the screen. I think I made my own for this too, and I got to turn my head this way to look at it, but we have from 0 through 31. This is the top row of the screen, and then as we go down each row, it increments by 32 because it's a 32 column screen. The bottom line is 480, and then there's 32 positions across from there. So there's a command called print at with the at sign, and you can place text precisely on a certain location on your screen, which is very handy. And I've used that a lot in games and stuff. Now here is also kind of breaking down your extended basic colors, right? So when we're in a crap. Now maybe we can get these back on track here. I don't know why the the alignment of this is kind of wackadoodle right now. Can I scroll this over? I can't scroll it far enough over, it doesn't seem like. But here's our colors here. So we have black, which is not available in any of our 4 color modes. Black is only available in our black and white modes. So then we have one P mode that gives us green, yellow, blue, and red. We've got another P mode option that gives us white, cyan, magenta, and orange. Here we have the modes. Okay, here's our different graphics modes. So in PMODE 4, we have 2 screen options. We have screen, you know, one. I think it's always screen 1 for graphics and screen 0 for text as it's coming back to me. So I would do screen 1, 0. 0 would be the low low colored palette where you'd have green as the foreground color and black as the background color. If I did screen 1, 1, I'd have the high order color palette, and I'd go to bright white. So in that old black and white mode, you had two different foreground color options. You had just green or just white, and they couldn't both be on screen at the same time. So in our high resolution modes, it was literally black and white, or what we call monochrome, right? So PMODE 4 is the highest resolution mode. Now what ended up happening as a nice little byproduct of early 80s analog technology is that a lot of games were written in this PMODE 4, and these televisions ended up doing what was called artifacting. And artifacting is when you had these alternating lines, these kind of black and white stripes, depending if they were on an odd or even pixel. Black and white stripes, there wasn't enough information between the black and white for our television to pick it up as a separate color, so you ended up getting red and blue as well. So most of the good CoCo games that were arcade style games used a PMODE 4 graphics mode and what we call color artifacting. So instead of it being only black and white, we got black and white, red and blue. Red was kind of orangish, blue was kind of sky blue. So these are kind of your colors here. So these are all of our P modes. So we have PMODE 0 and 1. PMODE 0 and 1 are the lowest resolution, and you either have the 2-color mode or the 4-color modes depending on your screen mode. We have PMODEs 2 and 3, which are the medium resolution, and you either have your black and white or your 4-color versions of that. And then you just have PMODE 4. There is no color version of PMODE 4, so PMODE 4 is the ultra high resolution ones. We haven't gotten into music yet, but it brings that down. So yeah, in the back of this manual are some abbreviations, so that's good. Now what I need to do is I need to go back and find where the heck we were. I need to go back to section 2. And we need to go back to chapter 14, get to the point, and here we are. So we just did this exercise here. It just showed us the colors. All right, so here we go. We're back to our do-it-yourself program. The do-it-yourself program says look on your worksheet and figure out where you can set some dots. I think we kind of already did that. I think I already kind of showed you how I can I picked the corners to do that, so I think we just did that. Now it says do-it-yourself program. Do you remember the random function, RND, from section 1? If not, review it and write a short program that fills the screen with random dots of random colors. Now that sounds like fun. So let's list this program out. So what we're going to do is I'm going to delete, can I do delete 30 through 40? I don't remember if that works. It does. Okay, so I have now just set the P mode, I've set the PCLS, I've set the screen. So let's do this. Let's say line 30. Okay, so we're going to say X equals RND 256 minus 1. That will give us between 0 and 255. If it picks 256, it will subtract 1 and be 255. If it picks 1, which is the lowest, it will subtract 1 from that and make that 0. And then I'm going to say colon Y equals RND 192 minus 1. That will give us our vertical resolution between 0 and 191. And then I'll say C equals random 8, and that will give us between 1 and 8. Bear in mind there are 8 possible colors. Only 4 will show up on the screen. So line 40 will now say PSET X, Y, C. PSET the coordinates with the color that we picked. Line 50 is going to go to 30. Pick a new position, pick a new color, and plot it. So when we run that, here we go. And what we can see now is the computer is just picking random pixels and random locations and random colors, and it's filling the screen in with pixels. It's pretty interesting to see this pattern evolve. And this is a very common thing that I would do back in the day as a kid. If I was going to make a space game, I would do like a for next loop and just have it print a bunch of random stars in the background to create a star field for me. And so right now you can kind of imagine these as stars in the sky, right? So that is kind of cool. Let me do one more one more thing here. So let's do a list. What I also want to do is I want to occasionally change the screen mode. And so let's do one more thing in here. Let's do an add learn 35. Okay. So I'm going to say S equals RND 500. Now, if S is greater than 400, then screen 1, 0, else screen 1, 1. So let's list that out. So what I'm going to do right now is I'm going to have the computer, as it's plotting pixels, it's also going to be picking a random number called S. And it's a kind of a crapshoot on what number it's going to pick. But I'm going to say if this number is high, whenever you pick a high number, change the screen to 1, 0, which will completely flip the colors, which gives us green as the background and yellow, red, and blue. But if you don't pick a high number and you're in low number, switch us back to the high order screen. So let's see how this runs right now. So you see that every now and then the screen will flash. And this was the only thing we had on the color computer that resembled paletting, right? And so like on an Atari computer and a lot of the 8-bit computers and in the arcade machines, you could put a single color on the screen and then you could adjust the palette register of that color so that same image would kind of flash and cycle with different colors. Atari was infamous for taking maybe 4 colors on screen but continuously changing what those colors were. Like if you look at the game Centipede only had about maybe 4 or 8 colors on screen, but every time you got to a new level the colors changed. And so the color value hadn't changed from whatever the 4 or 8 colors were, but the palette register of what that color looked like could be changed. Color computer doesn't really have these palette registers. It just has 2 screen modes for any of its graphics modes. So you can basically change to one of 2 color options, a preset color option. So you've got color option 1, green background with 3 other colors. Color option 2, white background with 3 other colors. You can flip back and forth, and what a lot of games did is they would do this flashing, like whenever you crashed into something you would see a quick flash on the screen. So it was a cool way to make the screen flash and get your attention. But right now we're just writing a little simple program that's going to sit here and continuously do this. You know what I should do as well? Let's do one more thing. Let's actually do this. We're going to do this because the reality is on line 30 is that there really aren't 8 colors for use. There are really, I'm going to delete everything else. Okay, there's really only 4 colors, and those colors are 0, 1, 2, and 3. So what I'm going to do is I'm going to say that C equals R, okay, insert. I to insert. C equals random 4 minus 1. Let's list that out. Okay, so C equals random 4 minus 1. So it's going to pick 1, 2, 3, or 4, and then it's going to subtract 1, so you're actually going to have 0, 1, 2, or 3. So every now and then this might actually erase one of the pixels too, because if I put a color 0 as a pixel, it just changes it to the background color as well. So now when we run this, we might see every now and then that pixels will disappear, because if I didn't add that option and I let this thing run long enough, eventually the screen would fill in with random colors and all of the white or the background would go away. But now I've added the option for a color to actually become color 0, which is the background, and I've added the ability for pixels to do this. This is another kind of cool effect. If you're doing like a black and white mode and you want stars that twinkle, you might want to just have your game randomly draw a star in either one of 2 colors, and so that way sometimes it might reset a star and have those stars kind of twinkle and stuff. So right now, again, we're just putting random pixels on the screen. We're just doing some graphic noise here, and then occasionally I'm randomly changing the color screen mode, kind of flickering those 2 options here, and it's kind of cool. So right now, this is the basic building blocks of graphics, is putting an individual pixel on the screen. And there's lots of things you can do with this. You can You can do things like a for next loop and have it draw a line by just calculating a whole series of dots. We could do things like that. You could do things randomly. There's different ways to do it if you really wanted to and you got out that graph paper. You could write in a whole bunch of statements where PSET this position with this color and PSET that position of this color, and you could manually write all that in and do it that way. You could put those coordinates into data statements where you could just fill in a bunch of data statements where say data x comma y comma c, x comma y comma c, and then you could read in all those data values, and as you're reading them, plot them on the screen. So there's a lot of ways to get pixel data on the screen. I think that might be an interesting little also way to do this instead of doing this randomly right now. And actually, I'm going to save this. I'm going to save this one called Random Pixels. I'm going to save that program called Random Pixels. And if you're wondering how I'm saving this, when I first did the video, I showed you how to set up VCC. I showed you also how to get a blank floppy image from the Color Computer Archive and save that image into your virtual color computer. So when I do a dir, I have been randomly saving some of my programs as I'm working on this if I ever want to come back and do them. So what I want to do now is I want to take this same program here and I want to delete line 30 through 50. Now when I list this, we just have this. So I was talking about for next loop, right? So, okay, so let's do this. 30 for x equals 0 to 255. Okay. C1 equals RND 3. C2 equals RND 3. What I'm going to do right now is I'm going to start on position 0, work my way over. Actually, let me just I'm going to go around. And so I was trying to get real fancy here. So 30 for x equals 0 to 255, color equals random 3. There's really only 3 colors you can choose. Now, line 40 is going to say PSET x comma 0 comma c. Next x. So what's going to happen is I'm going to start at 0. I'm going to pick a random color. I'm going to set it. I'm going to go to 1, pick a random color, set it, and so on, and I'm going to go all the way across. So I'm going to create a striped line, a speckled dotted line of colors across the top of the screen. I'm going to start from the top left-hand corner, go from left to right. Now we're going to go down. So now I'll do line 50. Okay, for y equals 0 to 191, colon c equals random 3. 50. PSET 255, comma y, comma c. 255 is hard right. Comma, next x. So I'm going to go over, I'm going to go down. Now we're going to go left. Okay, so this is another cool thing which I don't think the chapter told us about, but oh, I'm an idiot. I'm an idiot. I just retyped line 50. So let's do this. Okay, 50 for y equals, you know, that line 50 is already set. We'll just do a 45. 45 for y equals 0 to 191, c equals random 3. Let's list that out. Clear the screen, set the screen mode. We're going across, we're going down. Now I'm going to go left. So now we're going to do line 60. So for x equals 25520, step -1. I don't think the chapter covered this, but you can start at a number and work your way to a lower number, but you have to change your increment. Usually we say for x equals 1 to 100 and we're counting forward. You could say for x equals 500 to 1 and you could count backwards, and you can step it. Even in forward counting, you can step things too. If I wanted to count from 1 to 100 by 5s, I could say for x equals 1 to 100, step 5. It would go 5, 10, 15, 20. So you can step your for next loops by an increment, either forward or reverse. So I'm going to start at 255 and work my way backwards. I'm going to pick a new color. Color equals random 3. Line 70. not 60, but 70. PSET X, comma 191, which is the bottom of the screen, comma C, which is the color. Next X. Now I'm going to start at the bottom and work my way up. So line 80 is going to be for Y equals 19120 step -1 colon color equals random 3. Line 90 is going to say PSET 0, comma Y, comma C. Next X. Line 100, go to 100. Let's list this out again. What are we doing here on the screen, people? We are setting the P mode. We're clearing the screen. We're setting the color mode. Screen 1 means graphics. So 1, comma 1 means 1 is graphics, and then the second one is either the high colors or the low colors. If I did 1, comma 0, I would be using the low colors, which has the green background. 1, comma 1, high colors with the white background. Line 30 is going to start at 0 and go to 255. It's going to pick a random color each time, and it's going to plot this X pixel on line 0, which is the top of the screen, and go all the way across the top. Then we're going to go all the way down the bottom, then all the way over, and then back up. So we're going to basically draw a box around the screen, and as we're drawing it, we're going to pick random colors along the way. So let's see what that looks like. Here we go. And we're plotting. Now I think I have NF error in line 50. What does line 50 say? And what does NF mean? Next without 4. Next X. Oh, so it's Y. I'm an idiot. Okay. So edit 50. Next Y. Oops. This is what sucks when you don't have a full screen editor. Now, the other thing I just realized is that I'm not getting the colors that I want. I need 1, 2, 3, or 4. I don't know what's going on with the colors here. Some of those colors look like crap. What the hell were the color modes again? In our extended basic screens, we are going to get, okay, so this would be 1, 2, 3, 4, I guess. These are my 4 colors. So maybe I don't want buff, so maybe I want to do 3 + 1. I forgot how that does it. I don't know if it does a color 0. I don't know what the hell it's doing. All right, so let's just let's list this out again. And okay, let's edit 30. Let's edit 45. And by the way, what am I doing right now? There's a way to jump to the end. So I typed in 99 in the keyboard and hit spacebar. It just moved over 99 characters, which is the end. Now I'm hitting backspace. I'm hitting D to delete the 3. I'm hitting I for insert. I'm typing in 4. I'm hitting enter. I just got rid of that. Edit 60. 99 space gets me to the end. D to delete the 3. I to insert to 4. I don't know how to get out of insert mode, so at this point I just hit enter. Too lazy to go look for it. Edit 80. 99 space. D to delete. I to insert 3. Enter. Ah, shoot, I'm an idiot. Edit 80. 99 space. Get to the end. D to delete. I 4. Enter. All right, so now I'm picking 4 colors. Let's run the program. We're going across. Yeah, and I don't like the fact that sometimes they're white. Now we're going down. And that's fine. Maybe the white's nice for contrast. These are the various 4 colors. Now we're going to the left. And you notice this is kind of slow, right? This is the speed of basic. And now we have an error, syntax error in 80. For the step not work? Oh, it's C equals. Okay, edit 80. Okay, instead of C plus. C plus random, it's supposed to be C equals. Can I do C for change? Yeah, that's better. C to change. I just hit C to change and change that to equal. That's kind of what I need. All right, let's list that again. Now, let's run the program and let's see what happens. We're going across, people. And we're off. We're off to the races. And we're going down, people. And we're going down. Lucky Strike's in first. And whose line is it anyways in second place? And coming up in the rear is It's Nobody's Business. And we're coming up here and oh, next without 4. I screwed up again. I'm a freaking idiot. Okay, line 90, edit 90. It's taking me like 4 hours. 99 space to get to the end. C to change. Y. By the way, if you don't specify a variable and you just say next, it will automatically assume the one you're talking about. But sometimes when you have loops inside of loops, you have to specify which one you're looking for. All right, let's try this one more freaking time. Yes, and we're off, ladies, and Lucky Strike's in first place, and it's going down, and he's turning the corner, and he's turning the corner, he's going down, it's going down. Where's he going to go next? He just turned left, ladies and gentlemen, and he's going across. Oh my goodness, where is he heading? Will he fly off the screen? And no, he did a hard right, and he's going back up towards the top. And it's Lucky Strike for the win. Boom, we just plotted all the way around the screen. And so this is illustrating the fact that if you understand how to manipulate a X coordinate, a Y coordinate, and a color, you can put a pixel on the screen in your choice of a vivid array of roughly 3 colors on a fixed background color. The irony of the color computer was how little color and how few color options it actually gave us. But compared to the TRS-80 Model 1 and 3, which gave us no color, it was black and white, having 4 colors was an improvement. We'll give you credit there. Why are these colors the way they are? It has to do with the fact that Tandy used Motorola chips. It uses the Motorola 6809 processor and a Motorola, what is known as a VDG chip, Video Display Generator chip. And that chip that Motorola used had predetermined capabilities. Those capabilities were interesting, but weren't quite on par with what other contemporary computers could do that were also capable of doing color. So the Apple II computer had a text mode that I believe would give you 16 different low resolution colors on screen, where we only had 9. The Atari computer had graphics and text modes that could give you 16 colors on screen, and you could palette between 255 colors. So any one of those colors you could cycle through and create rainbow effects and animation effects and flashing effects. So other 8-bit contemporary computers were capable of higher resolution graphics and more color graphics. So the color computer was very interesting, but it wasn't, let's just say, groundbreaking compared to other machines of the time. But as you all know, if you're watching this video, you love your color computer. But yes, some of the design choices you kind of have to question. And it wasn't until the Color Computer 3 that the color computer really got more like actual color. So I think I've probably been talking a really long time. I have no idea how long I've been talking. I haven't even finished chapter 14, but I think I'm going to end this video here, and we'll make this chapter continue into more parts. And so we've basically done part 1, which is setting pixels on the screen. I hope you've enjoyed this. I'm sorry I babbled so long, but if you are interested in how graphics are produced, this is your first introduction to that concept on how the color computer does it anyways. All right, guys, I am the original gamer, Stevie Stroh. We got more to do. As soon as I finish recording this and stop this recording, I'm going to start another recording and record the next part and the next part and the next part. I'm hoping to crank out a good 3 or 4 videos today and release them all. So if you need more graphics, if you need more CoCo, it's coming. Thank you for watching this. I'm looking forward to your comments. Throw out a comment. Let me know what you thought. If you're new to my channel, make sure you smash that subscribe button. If you think anybody else is crazy enough that might find this old retro programming series interesting, share it. Share this video, share this playlist, share my channel with people you know on social media. If you're in any retro groups, share it out on that group. Spread the word. I would appreciate getting other people coming in and seeing what we're doing. We're just getting started, people. We got a lot more pixels. We got a lot more graphics. We got a lot more commands to cover. So we'll be back. Until then, CoCo forever. Hashtag CoCo Fever. Bye-bye now.